So this is the given problem. So now we want to write the given data for the solution. That is given, that is a steel shaft of 35 mm. So diameter of the shaft is D is equals to 35 mm and 1.2 meters long. So L is 1.2 meters and held rigidly at one end has the hand wheel at 500 mm. So diameter of the hand wheel capital D is equals to 500 mm. So in diameter, key to the other end, the modulus of rigidity of steel is 80 GPa. That is, C is 80 GPa. So we have length, diameter and modulus of rigidity. So now what we do is, you know that if radius is, diameter of the shaft is 35 mm, then radius small r is equals to 17.5 mm and capital R is equals to 500 by 2, that is equal to 250 mm and this is 18 gigapascals, that is C is equals to 80 into 10 power 3 Newton per mm square. And we know that here we have another one, torsion. Torsional shear stress is 60 megapascal, that is tau is equals to 60 megapascals, that is 16 Newton per mm square. Now at first condition, at condition 1, load applied to the tangent to the rim of the wheel. So when a load is applied to the tangent of the rim, so that is when load is acting on this direction or in this direction, and then it is wheel is acting on rotating in this direction, then load is applied on this direction, so it is tangent to this. Now we know that W is equals to, capital W is equal to load applied to the tangent to the rim of wheel. So load applied to the tangent to the rim of wheel is W, capital W. We know that torque applied on the hand wheel, so torque applied on hand wheel, that is T is equals to capital W by capital R, that is we don't know W value, so we know R value, capital R value, it is 250 radius of the hand wheel, so it is 250 into W Newton mm. Okay, next, polar momentum of inertia of the shaft. that is polar momentum is equal to J is equal to pi by 32 into b power 4. So when we substitute the values here, then pi by 32 into, we know the d value, that is 35 mm power 4, we get 147.34 into 10 power 3 mm power 4. So this is the value of polar momentum of inertia of the shaft. And next, now we know that T by J is equals to tau by R. We know that this equation, so from substituting the values in this equation, we get W value, that is T is equal to 250 W by 147.34 into 10 cube is equals to 60 by 17.5. So that implies except W remaining all terms into together into one side, then we get W is equals to 60 into 147.34 into 10 cube by 17.5 into 250. So then we get W is equal, capital W is equal to 2020 newtons. This is the load applied tangent to the rim of the wheel. So we have find out the first one, that is what is the load applied to the tangent to the rim of wheel produced to the torsional shear stress of 16 megapascals. Then we have substituted all the values, so we get the answer is W is equal to 2020 newtons. Then in second condition, that is number of degrees which the wheel will turn when load W is equals to 2020 newtons, that is same weight, that is applied load. So let theta is equals to required number of degrees. So we want to find out the angle. We know that one equation, that is capital T by capital J is equal to capital C theta by L. So by substituting all the equation here in this equation, all the values, so we get theta is equals to T into capital L by J into capital C, that is equals to 250 into 2020 into 1200 by 80 into 10 cube into 147.34 into 10 cube. So then we get all the solving to the calculation this all the values, then we get theta is equal to 0.05 degrees. This is the required angle for the number of, this is the angle for the which will turn when load is 2020 newtons.